Good morning, mathematicians. I wanted to talk about some of the material that you'll need to know for the tests and appropriate level of work. So you'll want to have the unit circle memorized, the standard unit circle, so 30 degrees, 45 degrees, 60 degrees, 90 degrees, and all the multiples and all the x and y coordinates. You'll need to know the definition of the unit circle, which is a circle centered at 0, 0 with radius 1. We're going to need to know the definition of a radian as a unit of measuring distance where the length is equal to the radius of whatever circle you're talking about. So in the case of the unit circle, a radian would be 1 unit long. All right, you'll also need to know 3 sets of definitions for the 6 trig functions. So the first one is what I call the triangle definitions, which is based off of, you might have heard the acronym SOHCAHTOA, but the ratios of the sides of a right triangle. So opposite over hypotenuse, adjacent over hypotenuse, tangent is opposite over adjacent. And you'll have to know these for the other 3 trig functions, which are just going to be the reciprocals. You also need to know the definitions of these in terms of x and y coordinates on the unit circle. So the sine function is just the y values of your pencil as you trace around it. Cosine's the x, tangent's y over x. And you'll need to know these definitions, a third set of definitions. These trig functions defined in terms of other trig functions. If sine's the y value and tangent's y over x, and tangent's also sine over cosine. Cosecant is 1 over sine. Secant is 1 over cosine. Sine is 1 over cosecant. And cosine is 1 over secant. All right, so you need to know all those. So some other things that I want to say about appropriate level of work. So you might have encountered a problem similar to this. I'm kind of making this up, but so let's say we want to set up the trig ratios for all the sides of this triangle. So we need to know the length of this side and the length of this side in order to be able to set up all of our trig ratios. Okay, so one way we could do this is I can set up a ratio like this. Sine is opposite over hypotenuse y over 12 and solve for y. And if you have a scientific calculator, you could plug this in. So make sure you're in degree mode when you do that because they're degrees. 12 times sine of 40, I get 7.7134 is equal to y. And then you could use a variety of methods to solve for x. I could set up another trig ratio and solve for x, or I could use the Pythagorean theorem and solve for x. Either way, okay. However, I tend to not like to ask questions that require punching things in the calculator. So an example of something I'm more likely to ask you, and you want to be able to really do this kind of both ways. This is a similar problem, but with a angle that's a standard angle that you should have memorized. So to solve this, I could set up a similar sort of ratio that we did on the previous example here, y over 12, solve for y. But because I have the unit circle memorized, I know that this is actually the same as root 2 over 2. Solve for y again. 2 root 2. And I could do the same thing for x if I chose to. Cosine of 45 degrees is adjacent over hypotenuse. That's going to be root 2 over 2. Multiply both sides by 12. We get this. Same thing. And that the side should be the same as this is actually an isosceles triangle, right? So anyways, I just want to point out you really should feel comfortable doing this both ways. Okay. If you've looked at the practice test, you also might note you'll see things like evaluate, which means to ascertain the output of the function of things like this. So this is not a standard angle on the unit circle, right? If you look at a normally labeled unit circle, that's not on there. The unit circle only labels angles between 0 and 2 pi. This is below 0. So what I want to do is find a coterminal angle to negative 7 pi over 3, and I could do that by adding 2 pi, find a common denominator, this is still not on the unit circle, so I'm going to keep adding 2 pi, and we get 5 pi over 3. So now that I have an angle that is on the unit circle, I could go about just writing down in this case, the y coordinate of that, and then that would be the final answer for this problem. But what I'm trying to communicate is what I'm looking for you to do on the test, and there are a couple of reasons why I'm looking for this, is for you to be able to show this work and find where that standard angle is. One, being comfortable with fractions is super important, especially when you go on to take calc. I know not all of you taking calc, but so I like to see that you're comfortable with all this fraction manipulation that you're going to have to do anyways. And then second off, some people's calculators could actually just spit out the correct answer for that, not in a decimal form, but in the correct symbolic form. And by that, I mean just as a fraction rather than a decimal. And I'm not looking for you to be able to punch that in your calculator. I'm looking for you to be able to demonstrate some understanding of what's going on here, right? So you should have that unit circle memorized. This angle, 5 pi over 3, is on the unit circle, so you should be able to walk through the process of finding a coterminal angle and looking up that y coordinate without having to punch any of that in your calculator. Okay, well, I hope this has been helpful, and thank you for watching.